and shift operator is the binary operator. That means it needs two operand to perform task, and it will not modify the operands and not applicable to real numbers, float and double. So k is equal to I left shifted by j. That means I left shifted by j times. So I is equal to 10, j is equal to 2. So 10 left shifted by 2 times. So 10 left shifted by 2 times. That means first time 110 will shift to one left side and automatically 10 add to at the end. Similar way one more time. So automatically 10 add and our output is 40. So this is the shortcut equation for that. Result is equal to number multiplication with 2 raised to shifts. Right shift, every number is shifting to right side. So 10 right shifted by 2 times. So here 2 times 10 will right shift, and then output will be 2. Shortcut is result is equal to number divided by 2 raised to shifts. So this is the equation. Then we have see the most important programs, how to set, how to clear and how to toggle or complement a bit. So using these three logics, you will find that you will set particular bit, you will clear that bit, and you will toggle that bit, and you will also find that bit is set or clear. We have seen this part. Next, today we will see increment and decrement operator. So plus plus, that is increment, minus minus, that is decrement. These both are unary operator. So unary operator, that means it needs one operand to perform task. Here pre-increment and decrement, post increment and decrement. So pre, that means plus plus, then here my variable, and minus minus, then variable. Here my variable, then plus plus, variable, then minus minus. Most important thing is this operator will modify the operands. And we cannot able to write here constant plus plus 10 plus plus 11 directly. We have to write here variable supply and constant not supply. Plus plus, that is the increment by 1, and minus minus is decrement by 1. Suppose I will take one example, I is equal to 10, then I will do I plus plus. So my output will be, suppose I will print here I, so my output will be I is equal to 11. Suppose I will do plus plus I, then my output also 11. Suppose I have written I plus plus and plus plus I both, then my output will be not 11, then my output will be 12. Why? Because here it will change to 11 and here it will change to 12. So here rules for pre-increment. For pre-increment, first increment it, then assign it. That means suppose I will take integer I is equal to 10, comma j. Here I will write j is equal to plus plus I. So what is my output I and j?
11.
11.
11, 11. Why? Because here I is the pre-increment, first increment it. So whatever the value of I, increment by 1, so 11 here, and 11 will store into the j. Next is for post increment. So it means first assign it, then increment. Suppose I will write here integer I is equal to 10 and j, and here I will do j is equal to I plus plus. This is my post increment. Now what is my I and j?
10 and
Okay. 10 and 11.
j is equal to 10.
J is equal to 10 and I will be,
11.
yes, right. Here what happened? First assign it, then increment it. So here my j will become 10 and I plus plus, after execution my I will be 11. So similar case with the pre and post decrement. So you have to try by yourself for the decrement. Here what is my output? INJ 11 and 10. So in the case of pre it's plus plus, and in the case of post, so GCC 11 and 10. So we have already seen these two value. Now what is output?
22.
Where I or J?
So I will be 11 and 21.
I is 31 and J is 21.
Yes, 10 plus 21.
Exactly.
Because I is equal to the equation.
Why?
For
Because here this is
first
the
assign.
post
Yeah.
first assignment. So my I modified to 11, and here we are doing to plus with plus plus J is 21.
21.
Sorry, here 10.
Yes.
Suppose I will take here plus plus I, then 32 and 21.
Yes.
Okay, understood this. Next, now what is my output? So printf is doing execution is right to left. So first this will execute, then this will, and then this will. So what is my output here?
10.
Here
10.
11 and 12.
And
Assign same value percentage day, right? Practically is.
yes, same variable I am doing increment here. Here my post increment. So first it will print the 10 and then increment. So here my I become 11. So it will print 11 and then do the post increment. So here my I become 12. So percentage D is for the decimal. I want the output in the format of decimal. So see my output 10, 11 and 12. Suppose I will take here. What is output here?
11, 12, 13.
Yes.
13, 13, 13. Think so.
Why?
Okay. No, no, no. First 11, 13, and 13. 11, 12, 13. Yeah.
We want this output, but we will get this output. Output is 13, 13, 13. But your expectation is right. Here output is wrong. Your expectation is right. We want 11, 12 and 13. But it is compiler is giving 13, 13, 13. Why it is giving? We will come to that part later. Suppose I will here use scanf. I will not assign any data. I will take data from the user. And I will enter data 10. Now my output is 11, 12, 13 as expected. So why this? This is the most important concept. Next one is,
Address of
so scanf is scanning runtime. So it is storing in the memory at the runtime, and our compiler is allocating memory at the runtime. And if I will write normal integer I and like this only, and I is equal to 10 here. So here my data is stored at the compile time. So in the RAM, whatever the particular address is allocated for I, in that address, my 10 data is stored when my executable file is already ready. And in the scanf, there is the blank space available for I. So it will be the allocate data at the runtime when my executable file is already ready and running. So that is the difference is there. So this difference understood, scanf and normal integer I compile time and runtime memory allocation. So next is the code optimization. So code optimization will optimize your code. So whenever we try to optimize our code, so first thing is we will reduce size. The second is to increase performance. So what happened in the regular cases? So first reduce size, for reducing the size. Suppose example I have taken integer I, J, K, L. Sorry, this is the L. So I am using I and J, K and L I am not using. Okay. So in my code at the compile time, compiler will check these two variables are not used anymore in this code. So compiler automatically neglect that and it will not allocate space for K and L. And second thing is to increase performance. So this is my RAM. This is my a.exe file is executed in the RAM and this is my processor. So knowledge purpose, I am giving you the background. Inside the CPU, we have different cores available. So these are the four core. There is the eight cores. There is the two cores. Different core available inside the CPU. That is the processor. It's working on the different cores. So more cores, your speed will increase. So whenever we execute our program, so it will make the copy in the RAM. So first allocation. So then after it is giving to the CPU. So CPU we have a different cores available and it is running program inside that. So we have two types of different RAM available. One is the static RAM. This is only for your knowledge purpose, and another one is the dynamic RAM. So whenever we execute our code, so it is loaded into the dynamic RAM first, and then after it is giving to the static RAM. Static RAM is inside static RAM, there is one cache memory available. And inside processor also one cache memory available. So inside processor, whatever the cache memory available, that is called register. Inside the register, it is storing the data. So what is the exact meaning of the cache memory? Anyone know?
Temporary memory?
Yes, exactly. Cache memory is the temporary memory, but it is for the optimization. Suppose something we are doing repeatedly. So what a cache memory will do? It will store that particular repeated task. So whatever the things that is repeatedly we are doing, that it will store inside that. So whenever you open the website, at that time they are asking to accept cookies. So what is the meaning of cookies? So cookies also save in your RAM and in your database, that in your Chrome browser or any browser, that you are checking this part whenever you will come, at that time it will load immediately because that cookies are saved, that cache memory are saved in your computer. So similar way concept here. Some in the a.exe file, whatever the at the compile time we are running this code execution, so similar type of variable we are doing, at that time it is store one duplicate file. So inside the RAM, so that is the RAM is the static RAM. Inside the static RAM, it will make one duplicate file, one duplicate file. So instead of asking it directly from the memory, it will directly take from that stored data. So if the compiler knows, so write down this line in your book, know that you are some expressions you are repeatedly, some expression doing repeatedly, that time compiler make a duplicate file. So in the case of our microcontroller, it is storing inside the registers. So instead of directly reading from the memory, it will read from the registers. So because of that duplicate file, instead of reading from memory, it will directly reading from the registers or cache memory. What are the benefits of this compiler is doing, making a duplicate file and making the cache memory? Our performance will increase
Yeah.
because it is solving task in minimum time. So performance will increase, but accuracy will decrease. So how to optimize this code? So here we have written integer I is equal to 10 and we are doing repeatedly task. At that time compiler is storing in its cache memory in its registers. So whenever duplicate things will come, so it will take it from that only. So because of that reason here my output is 13, 13 and 13. So a compiler have not taken from the memory, but it have taken from the cache memory. So at the time of scanf is running at the runtime and runtime my whatever data is taking from the memory. Because of that reason scanf output is 11, 12 and 13. Understood this till now? Any question?
Yogin?
Mm.
Yeah, it means for the safer side, it is better to use scanf. Means if we are not using scanf, then it may be possible we are not getting accurate answer. Is it?
No. That part I will come. So
Okay.
scanf is useful for the taking runtime and
Mm-hmm.
in generally real life you are not using scanf anytime and printf
Mm-hmm.
also. So printf and scanf is for the learning we are using. Why we are not using printf? Because at the time we have to not display to anything. At the
Mm-hmm.
run in real life we are taking data, we are doing operation, we are sending to another communication protocols and doing like that way. So you understood scanf is running runtime and printf and it is storing in the cache memory. So
Yes.
there is one type qualifier is there, that is volatile. What is volatile? So volatile is a type qualifier. For optimization this type of code we have to use volatile type qualifier. Volatile integer I. Suppose I will take. So what is volatile? Volatile is type qualifier. So using volatile, it will not create memory in cache memory or it will not store data in the register. Every time it will take data from the memory. Whenever you will use volatile integer I, so at that time my I data every time it will take from the memory. It will not store in the cache memory. So it will not do any optimization. Using volatile, your accuracy will increase and performance will decrease. So we cannot take all the variables as a volatile. If we will take all the variable as volatile, so my performance will decrease and my code will running. It will take much more time. So whenever we need to do repeated tasks with the same variable name, at that time we will use volatile. This is the most important question for interview, why we are using volatile. So you have to give each and everything whatever you learn here. So in the normal things, it is making the duplicate file in the RAM and the registers. It is storing the whatever the repeated task. So it will store inside the register instead of taking from the memory. It is taking from the register. So because of that reason, sometimes our code will not give whatever the expected output. So because of that reason, we will use volatile and volatile. v- Using volatile, it will not make any duplicate memory and volatile is a type qualifier. So using volatile, it will not make any duplicate memory and accuracy will increase and performance will decrease. So this accuracy and performance part don't tell at the time of interview. What is the use case of volatile? That only you have to explain.
Can you take one example, Yogin?
Yes, yes, here. This is the example. I will run this code. Now my output is
So,
11, 12, 13.
so volatile means type qualifier means scanf, right?
No, it's not scanf. Scanf, that means
So we have to define volatile int. Okay.
scanf is completely different. Volatile is different. Printf is different. Integer is different. Everything is different things. Scanf, you have to find what is the use case of each and everything.
Scanf is just when we runtime, whenever we runtime we apply any, give any value to the integer I or anything which we defined. So this is what scanf, which we give input or user defined input, right? This is what
Yes,
scanf. So for cache we use only int I, right? And for all volatile we will save data I data on memory, not cache memory, repeated, not in register, right?
duplicate memory.
Yeah,
Yes,
okay.
exactly. Yeah.
So we have to define volatile int I equal to 10 for storing data in
So
memory, not
when you have to use volatile?
store repeatedly data.
So whenever you are using the repeated task,
Mm,
so I is incremented by one time. So whenever we are using the repeated data,
mm.
so at that time we have to use volatile. Scanf is useful for the taking data from the user at the runtime. Understood this volatile concept?
Yes.
Okay. Next is the control statements. There is two types. First one is the iterative. So this is new chapter. Control statement is the new chapter. So there is two types. One is the iterative and another one is the non-iterative. In the iterative is looping concept. So in the iterative, for loop, while, do while. In non-iterative is two types. One is the conditional and another one is the unconditional. Conditional is the if, else if, nested if, switch case. And unconditional is the go to control statement, break, return, and continue. So control statements are useful for controlling the flow of program. One is for the I want to skip some expression. So skipping some of the statement, execute some of the statement in set time. These are the main use case for the control statements. We are generally using all the control statements in real life, day-to-day life, for while, do while, if, else if, nested if, switch case, go to, break, return, continue. All are the things we are generally using. So tomorrow I will start from the conditional if control statement.